kind of make my own little graph and draw it. Okay, so if we were to, and actually I'm going to do it on one of these plane graphs just because, so you guys can see it. Okay, so you don't need to get on that page, you can stay on your page. So if we look here, my very first thing on the table says -6, -7. Okay, and so that is right here. Okay, and again, you guys don't need to plot these, so don't even, you're not doing it anymore. Okay, my next one on the table says -6, -1, so that's here. My next one says -5, -5. Okay, -3, 1, and 0, -1. Okay, so those are all the dots that they gave us on the table. Okay, and again, that's nothing that you need to do. Okay, so we're simply just by, and you can kind of figure out for yourself whether this is a function or not. So notice how these two dots are on the same line. So if we were to play connect the dots, you could connect these ones and you do them from least to greatest. But notice how these two are on that same -6 line right here. Yes? Hello. Yeah? Okay. So see how that's a vertical line? Okay, and so there's something with functions called the vertical line test, and that will tell you whether something's a function or not. So, is that having the x's repeated on your table, or is that the y's? Which ones are repeated? Look at your table. The x's or the y's? The x's. Okay, so if the x's repeat, okay, then it's automatically not a function because it will not pass that vertical line test. Okay, so for we're only allowed one input for every output. Okay, by input, remember we talked about putting our money in the vending machine, and then the output is whatever we get. Okay, so we can have plenty of different outputs, but we can only have one input on our list. Okay, so essentially, the x's cannot repeat. Okay, when they do, we get that vertical line. So, do the x's repeat? Yes, so then no, this is not a function. Okay, so look at number 3. Okay, do the x's repeat?
No.
No, so then yes, it is a function. Okay, 5. Do the x's repeat? Yes. So then is our answer yes or no? No. So it's kind of like weird to think about. We're kind of doing the opposite here. Okay, look at 7. Do the x's repeat?
Yes.
Yes. So then is it a function?
No.
No.
Yay.
Okay, number 9. Do the x's repeat? No, so then is it a function?
Yeah.
Yes. Okay? Yes, sir. So if the y repeats, then that looks like, which one are you looking at? Number what? So -6, 5, 0, 5. So again, so those are both of our 5s. Are they right on top of each other? No, so this is a horizontal line, okay, which is totally fine. We cannot have a vertical line. So the y's repeating is totally allowed, okay? Okay, so let's look at the mapping. Okay, so we looked at these the other day, and again, you can graph these, okay? And I'm going to, so you're looking at number 11, I'm going to just draw it on the graph so that way I can erase it, okay? So notice how that -3, where is that number going to?
4.
4, okay? So we have -3, what is it? Positive 4? -3, 4. What's my next one? -1 to what? To -7. My next one says 0 to what? Okay, look at these ones. This is super important. Look at it. 0 to what? 0 to 0, and what?
6.
0 to 6, okay? So 0 to 6. Okay, and then we have 6 to what?
1.
6 to 1, okay? Now, do any of the dots, are they like on top of each other? Yes, which dots? The zeros, okay? So if we were to play connect the dots, okay, you're gonna get a vertical line right here, okay? So which is that that's not allowed, the domain or the range? The domain. So notice how there are 2 arrows coming from the same number on the domain. Does everybody see that? Okay, so then that makes it not a function. Okay, so number 11 is going to be a no. Okay, so we cannot have 2 arrows coming from one number. Okay, so this one is going to be a no. Okay, so look at 13. Is this one a function? 13, is it a function? No, because how many arrows are coming off something? 3 off of what? 7. Good. Okay, number 15. Is this one a function?
Yes.
Yes. So even though that there are 2 arrows going to this -5, we're really only looking at the domain, just like the other one. Okay, so this one is going to be a yes. 17. Is this one a function?
Yes.
Try again.
No, it's not.
No, why not?
Because the bars right here.
Off what? Off the 1. So notice how the 1 has 2 arrows coming off the 1.
Okay.
Okay, so that makes it not a function. So this one is going to be no, it's not a function. Okay, 19. Is this one a function? Yes, why? Yep. So Dee Dee, look at this one. See how he has 2? That don't matter. We're only looking at this one. We're really only looking at that box. Okay? So this one is going to be yes, it is a function. Okay, the last part, we should be able to tell if something is a function by a graph or not. Okay? And here's what I can tell you. There's like, so it's called the vertical line test. Okay? If you were to take your pencil and start dragging it across that graph, by the graph, I don't mean this background, I mean this one. Okay, that picture. If it's making any sort of vertical line, so a line like this is made up of a bazillion million points until they're all connected to make a straight line. Okay? So if we have a vertical line, then that's when we have those 2 on the domain that are crossing. Okay? And so when we're looking at a graph, I can tell you right now, anything that's vertical, up and down, okay, even if it's just for a second, even if it's like this, okay? If it's a graph and it's going and then it does this, okay, this part makes it a no, okay, because there's a bazillion dots right here, okay? Or if it's a closed shape, okay, so if we're looking at a closed shape, okay, if I would draw a vertical line, see how it's touching here and here at the same time? We could say that was 0 or whatever, okay, that's going to make it not a function, okay? So if we look at 21, is that one a function? Yes, it is.
Yay.
Okay, so this one's a yes. Okay, 23. Look at 23. Is it a function? No, why not? It's the vertical line. It would fail the vertical line test. Okay? Because we can see here at 0, or at 5, 0, there's a point. Okay? At 5, 1, there's a point. At 5, 2, there's a point. So this one is a no. It's not a function. Okay, 25. Is this one a function? What's everybody's vote? Is it a function, yes or no? It is not. So if I would take my pencil and draw a mark, and we could say even here at the 0 line, Okay, see how it touches right here on the graph and right here?
Yeah.
That makes it no, it's not a function, okay? 27. Is this one a function?
No.
No.
That's what everybody's going with, no? Okay, same thing, pick a spot. It doesn't matter whether I choose here or if I choose right on the 0 line. Okay, it's not a function. We can see that it touches the graph right here and right here. Okay, so this one is gonna be a no. 29, is this one a function? 29, is that a function? No, it's not. Okay, same thing. I could draw a line here, and this one's kind of tricky. So this spot, if you would draw that right here on the end, and I'm using a marker, so, but we can see that it touches the graph here, 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 all at the same time. So this one is going to be a no. Okay, so, and here's the cheater way. Anything that is a sideways shape, okay, because notice how these arrows are pointed sideways and not up and down. Okay, right here and right here, they're kind of going sideways, is going to be a not a function. Anything that is a closed shape, circle, square, triangle, not going to be a function. If the arrows are both pointed up or the arrows are both pointed down, then it probably is, okay? I don't want to say always because there are cases like what if the arrow started heading back the other way? Okay, I could have something that has both arrows up, okay, but goes like that instead, okay? So, most of the time, if you were forced to guess if the arrows are going sideways or we have a closed shape, then I would go ahead and guess no, okay?